We need to measure distance. That's the number one thing we measure. What do we start with? We got to have a unit. They picked the meter. Do you know where the meter comes from? Why is it this length? They chose something that everybody in the earth has access to. They chose something everybody could get their hands on, and that's the earth, no matter where you're at. This distance was originally defined as the 1/10,000,000th of the distance between the North Pole and the equator. They took that distance, they didn't take a rope, but they split it up into 10 million pieces. Voila! Meter. They need something shorter. They didn't cut it up into anything except tens. They split it up into 10 pieces and they got what's called a decimeter. There's prefixes involved in all of this. 1 meter, 10 decimeters. Just like our money system, dimes, cents. They need something smaller. They split it up into 10 again. Centimeter, centimeter, century, centurion, centipede. The prefixes mean 100th. They split that up into 10 more pieces. A millimeter. Just like millipede, million. I don't know if you know this, but a million is 1,000 thousands. 1, tenths, hundredths, thousands. They needed to have something bigger. They need a larger unit. They put 10 of these together. 10 of these make a decameter, about the length of a room, normal-sized classroom. 10 of those together would be a hectometer, like a football field. That'd be 100 meters, a little bit longer. Put 10 of those together, you get a kilometer. It's all based on 10. Here's why it's so nice. If you had 4 kilometers, that would be 40 hectometers, 400 decameters, 4,000 meters, 40,000 decimeters, 400,000 centimeters, 4 million millimeters. Move the decimal point because it's tens, tenths. Well, that's distance. Now we need to measure something else, capacity or volume. We need a unit. We need a container. They made one from the meter. It's all connected. They made a box, not out of plastic, probably metal or wood, 1 decimeter by 1 decimeter by 1 decimeter. That amount of liquid or whatever is called a liter. But they needed something smaller. They split it up into 10 pieces. It's called a deciliter. They split this up. This isn't hollow, but if it was, it'd hold a deciliter. Split that up into 10. You get a centiliter. Split that up into 10. You get a milliliter. This is 1,000th of the original. Guess what happens if you need something bigger? 10 of these, deciliter. 10 of those, hectoliter. 10 of those, kiloliter. It would all work the same thing. The prefixes work just as well. What happens if you need to measure weight or mass? Sorry. Well, you need something that has weight, mass. Don't use rocks, sand, soil. They use something everybody in the world has access to, or better, water. A gram, 1 gram, 1 cubic centimeter. This is a cubic centimeter. 1 cubic centimeter of water, the weight of that, the mass of that, is called a gram. And guess what? If we want it smaller, 1/10 of it, decigram, centigram, milligram. 10 of these together, decagram, hectogram, kilogram. 3 basic units, 6 prefixes. It all works the same way. By the way, 1 cubic centimeter of water is 1 gram, which is, they're all connected. Ones, tens. It gets even better in square meters or cubic meters or even in science with newtons. But we won't talk about that today. The nice part starts with the meter, comes from the earth. Split it up into 10 pieces, 10, 10, everything's 10 times as big. 3 basic units, 6 basic prefixes. It all works so slick. You know what? Decimals are a lot easier to work with than fractions. I don't know if you ever thought about this. In the library, you could have the Dewey fraction system, but it's not called that. It's called the Dewey Decimal because they're so much easier. Move the decimal point. Grassroots Metric Campaign. See you on the web.